Hi, I am Varun Joshi and welcome to day 7 of our Jenkins Basics to Production course. Today we will take our day 6 pipeline and evolve it into multi-branch pipeline that auto discovers branches and PRs, builds the right job, be it the branch job or PR job, and keeps main releasable in a trunk based workflow. But before we do all these demonstrations, we will first understand what are multi branch pipelines and why they are so powerful. We will wire up an MBP to a private GitHub repository, open PR, manually rescan, and use our shared Jenkins file to build, push, and deploy a Dockerized Python application. So, without further ado, let's get started. Multi branch pipelines. It is a Jenkins job type that scans your SCM and automatically creates a child pipeline for every branch, PR, or tag. Let's break this definition. Firstly, I want to highlight that multi-branch pipelines are not a concept that is just limited to Jenkins. You have these things in GitHub Actions and GitLab CI built in. So in here in Jenkins, you create a multi-branch pipeline job, but when you talk about GitHub Actions or GitLab CI, you have the liberty of defining these things within the YAML itself. So the concepts that we are going to learn today are not just limited to Jenkins. Now let's dissect this definition. It's a Jenkins job type that we understand that scans your SCM. SCM is source code management, and in our scenario, the SCM would be GitHub. So what we are saying is it's a Jenkins job type that will scan my SCM and automatically is the keyword creates a child pipeline for every branch, PR, or tag. Now, your repository can have multiple branches. What we are saying here is based on how many branches you have or how many PRs are there in your repository or what are the tags that there are in your repository, it will automatically create a child pipeline. So with this definition, what we understand is multi-branch pipeline is an umbrella term, and that job type may have multiple pipelines within itself. So up until now, we were dealing with single pipeline jobs. We had a pipeline job, we defined the branch on which that pipeline job will be applicable, and that pipeline job used to do its job. But here what we are saying is we have a multi-branch pipeline job that will be applicable for all the branches or PRs or tags in your repository. As simple as that, and all of these things will be done by Jenkins automatically. You do not have to define the branches, you do not have to call out the PRs, you do not have to call out the tags. Now, what are branches, what are PRs, what are tags? We have seen this before, but a one liner wouldn't harm. So let's say we have a main branch. In the main branch is our primary code, which is always releasable. So now a requirement came in where we have to introduce a loan feature in our banking application. So what our developers will do is they will create a new branch. They will not touch the main because the main is protected. They will create a feature branch and they will start working on this code. Understand that when this feature branch was created, we were on this stage. So whatever the code was there for the application up till this point will be available to this feature loan branch. Now our developers will start working on the loan feature. That is what a branch will do for you. It's a separate line of work. It is your own copy of the code where you make changes. Then what is a PR? PR is, let's say, developers are now happy with the code. They have performed multiple pushes in the feature branch. They have performed multiple testings, and now they are satisfied with the entire code. So what they choose to do is they choose to merge whatever they have done into the main branch, and to perform that merge they will have to raise a PR. Why a PR, Varun? Why can't I push directly to the main branch? Often in production you will see main branches or any of your release branches are protected. You cannot directly push onto those branches. So what you do is you raise a PR. PR is a pull request. It can be thought of as a merge request. When this PR is raised, a certain checks are performed, and if those checks are successful, the merge successfully happens. And this is what you see here. And what are tags then? Now understand that tags are just releasable versions of your application. For example, if my application is running version 1.1, then 1.1 becomes my tag because the commit that is associated with version 1.1 is a releasable version. Now let me explain that to you in simple terms. For example, let's say your main has 10 merges, so 10 PRs that were approved. Now each of those PR could represent a version of your application. So tag essentially is a version of your application. So all those 10 commits that you see here could represent a tag, or a handful of those commits can be thought of as a tag. So again, in simple terms, tag is just versioning. Version 1 this tag, version 2 this tag, version 3 this tag, and it tags associate your releases with the commits on which those versions were decided, or those tags were decided. What we are saying here is, when you are dealing with a multi-branch pipeline can trigger a job, can trigger a build based on branches, based on PRs, and based on tags. And as we progress with this lecture, we will learn more about these things. So now that we have a high level understanding of multi-branch pipelines, let's see these pointers. Repository driven CI mirrors branching model, auto creates jobs per branch. So this is what we understood. If you create 10 branches, there will be 10 CIs that will be created for you. There will be 10 CIs that will run for you, and we will see how this works in the demonstration. The second point is Jenkinsfile first builds only references containing Jenkinsfile per branch or PR. So understand this point. I could have 10 branches. I may not want multi-branch pipelines to be running on a specific branch. How do I do that? What I do is I do not put any Jenkinsfile there. So what I'm trying to convey to you is, for a branch to be selected for the CI, there must be a file named as Jenkinsfile. So if I have this feature loan branch and I do not supply this Jenkinsfile in this branch, then Jenkins multi-branch pipelines will not be acting on that branch. So multi-branch pipeline will always be looking for branches or PRs or tags that have Jenkinsfile available, and this is the default name. You have the liberty, you have the option to choose a custom name as well, but as I always say, you should be sticking to the standards so that anyone who looks at your work can simply judge that yes, this is the Jenkins file. Third pointer is fast feedback, pushes and PR updates trigger CI. Now imagine, as soon as a feature loan branch is created locally and then as soon as it is pushed to the remote, your CI will run automatically because your Jenkins job detected that there is a new branch in the remote. And how it detects, how it works is a different story altogether. Right now, I just want you to concentrate on as soon as there is a new branch available and that new branch has the Jenkins file, Jenkins will take action if you have a multi-branch pipeline job. Next is lifecycle automation via webhooks, creates and retires job. Now it is up to you how you want to poll your SCM. Now maybe as soon as a new branch is created, a webhook is delivered to Jenkins, and based on that webhook, Jenkins will run the pipeline job on your newly created branch. Or Jenkins could be polling your SCM every 15 minutes, 60 minutes, 1 minute, 1 day, and so on based on your requirement. And if it sees there is something new, there is a PR or there is a branch or there is a tag that has the Jenkins file, it will run the CI, the pipeline on that branch, PR, or tag. Lower blast radius. And again, in lifecycle automation, you have webhooks and you have polls. You can poll the SCM. And then there is a third option, that is you manually perform that scan. So that is also there. The next point is lower blast radius. Isolate builds, keep main clean, and this is the beauty. So what happens is whenever I have a feature lone branch, for example here, my job will only concentrate on this part of the code. Main will always be releasable, and when I raise a PR for the merge, then we'll have new checks so that the merge that happens here is also releasable. And the next point is scales with teams. It is obvious. So if I have multiple teams, they can create multiple branches, and as soon as they create their branch, as soon as they push their branch to the remote, we know a CI will kick in as long as Jenkins file is available in that branch. Then auto discovers, we already understand, it will either poll or it will deliver a webhook, that is auto discovers. And prunes short-lived branches. So retires jobs in this point and prunes short-lived branches in this point. I want to relate these things to you. So understand, you have a feature lone branch, you perform your changes and you are sure your changes work fine. Not you are sure, there is automatic builds that happen, the pipeline that runs that tells you that it is green, your code works. You raise a PR and PR gets approved, and let's say it is merged. Once that PR is merged, do you really think there is a need for this feature lone branch? No, right? You don't need this branch once the work is done. Then you can delete this branch because I no longer need this. And understand, as soon as this gets deleted, my Jenkins will know that I was working on a branch called feature loan that had Jenkins file, but I don't see that branch anymore. So let me also retire the job that was created for that specific branch. And that is what this means, retires jobs. And here prunes short-lived branches, feature.loan, once the CI succeeds, will be auto deleted. Now I hope multi-branch pipelines are understood, and in the demo you will understand them more deeply. But here is one more thing I want to mention. In trunk-based CI/CD, MBP is the glue. Feature bug fix branches stay small, like we saw here. As soon as the work is done, you run the CI and the PR gets approved and the branch is removed. If there are failures, then the developers will again be working and then the same process will repeat. But the crux is, and We have learned this in day 2 of our course. When I talk about trunk based CI/CD, I want things to be super fast. My developers, they push the changes, the CI runs. If the changes are okay, the merge happens and everything is hunky and dory. So the failure or the success happens frequently and fast, so that the main is always releasable. So let's read this definition again. In trunk based CI/CD, MBP multi-branch pipeline is the glue. Feature bug fix branches stay small, PRs get tested automatically, and main stays releasable. Now, if you have any doubts, I would request you to go back to day 2 and see what is trunk based CI/CD. Essentially, in one line, the source of truth is the single trunk main, and then there are multiple feature and bug fix branches that will take over. Understand that in this lecture we discussed so many workflows. So if you have not watched day 2, if you're not watching this series in sequence, then if you already understand these concepts, it is all right. But if you want to brush up, if you want to learn maybe something new, then I would request you to watch this series in sequence. So in day 7, I'm back here. So this is all about multi-branch pipelines. Now, what I want to show you is a production flow, so that whatever we have discussed in theory makes sense. So once we discuss this production workflow, after that we will go to the demo, so that you first understand how the flow looks like in production, and then you implement that flow with me. So the heading for this is trunk based CI/CD multi-branch flow. So the diagram is numbered. We will see what happens in each step. So just to let you know, green color here represents the main branch, and main branch is the one that should always be releasable, and we are discussing trunk based CI/CD. So point number 1 is, let's say a requirement came in wherein your TL was asked that you have to change the font of the UI. The UI is no more appealing to the users. We have to use some sort of Comic Sans font or Arial font to make it beautiful. Your TL took that input and assigned that task to a developer that improve the UI font. So what will that developer do? That developer will create a new branch. And understand, since we are introducing a new feature, in a way we are improving something, in a way we named it feature. If there was a problem that we were fixing, we would have called this bug fix, and then whatever bug we were fixing. Here we are just making an improvement. We are introducing a new feature, so to speak. So we named our branch accordingly. We called it feature / UI font. That's step number 1. Now, why did the developer not modify this directly? Firstly, it is not permitted because this is a protected branch. And secondly, we all know this is a best practice that you create a new branch and then work on that. This new branch, whatever you see here, will hold all the code that was available up till this point, because it is at this point that this branch was created. Now, if there is a new something here, a new commit here, then this branch will not have any information about it, because this branch was created after this commit. Now there are ways to get around that. You have features like rebase, merge, and so on. We'll see them later, but for now, understand that this branch will hold all the code up till this point. Then step number 2 is push branch job. Now let's say our developer worked on the UI feature, our developer worked on locally, and we all know first the developer will work locally, and developer is now satisfied. So now what will the developer do? Developer will push this branch onto the remote, and this branch will already have a Jenkins file, And since this already has a Jenkins file and the developer has pushed it onto the remote, and let's say the remote is GitHub, Jenkins will detect that, runs on each push. Now that could be webhook or it could be a scan, and the scan could be a poll based scan or a manual scan. Then what happens is compile. We all know what compile is. Compilation is a process of converting the source code to machine code, and machine code if the compiler based languages are C, C++ or Go, and to bytecode. Bytecode is applicable when you are dealing with Java or C sharp. So essentially compilation is a process of converting the source code into machine or bytecode. Again, we have discussed these things in detail in day 1 and day 2 of these lectures, so do check that out. Now only compiler based languages will have the compilation stage, and it is not something that you have to do manually. There are tools, there are automation tools, there are build tools available at your disposal which can perform this compilation for you, like there is Maven for Java. Then you have unit tests. Now what are unit tests? They run small pieces of your code, maybe a function or a class, inside the test program. No server or app deployment needed. So understand this point. Unit tests can be performed when the application is not running. However, if I contrast this with integration tests that we'll see later, these tests warrant the application to be in running state. So unit tests can be performed when the application is not deployed. So they can be performed on your code. Now, Varun, but how will I perform unit test? Again, I mentioned that there are build tools available at your disposal. These build tools, they have certain plugins or add-ons that will help you perform these unit tests. And like I said before, there is Maven in Java which you can integrate unit test into. And then there are various other tools, like Maven will have this JUnit, CMake with Google Test. And there are different tools that can perform these unit tests. For example, JUnit is for Java, Unity is for C, GTest for C++, GTest is Google Test. Then you have PyTest for Python. You have to know these things at a very high level, at least at this stage, if this is the beginning of your CI/CD journey, because as you deal with specific projects that deal with specific languages, your understanding will deepen, because there is no point memorizing these things if you are not using it daily in your CI/CD pipelines, because we humans tend to forget things that we don't work in everyday life. So for now, just take this as a dump onto you, and once you progress with your learnings, these things will be in your fingertips. Then in this stage itself, so first we said compilation, then unit test, then there is linting. What is linting? Linting is a process of statically analyzing your source code for any stylistic or programmatic errors. Maybe there are unused variables, there are suspicious null checks, or there is inconsistent formatting. So linting will detect all those things and will tell you. Then the last one that I want to discuss is coverage. Now let's say you have 100 lines of code, but the tool that you are using for, let's say, code scanning only scans 80 lines. So your coverage is just 80%. And I should not use the word just, because for most of these checks to pass, the coverage should at least be 80%. So if your tool that you are using for your code analysis only scanned 80 lines of your code, only tested 80 lines of your code, then your coverage is 80%. So code coverage is an important parameter. A lot of pipelines will fail if the code coverage is less than 80%. So keep these things in mind. Then package plus build container image. Understand, we are not deploying anything right now. We are just performing packaging plus building container images. No deploy is happening. Now, I have written this based on what I have seen in general, but each pipeline is different, each project is different, so do not limit your imagination. Maybe you are performing some more tests in this stage. What I am showing you is a blueprint that you will often see in production. Then you have publish artifact metadata, SBOM. Let's dissect these terms. What is artifact? We know anything that results from a pipeline build is an artifact. So if you are receiving a file, that file is an artifact. If you are receiving a container image, that container image is an artifact. If you are receiving a .jar file after building a Java application, then .jar is your artifact. So in this point, we are saying we will publish the artifact. Now, what is publishing the artifact? An artifact like container image can be published into your image registry. An artifact like .jar can be stored in your artifact tree. Or if there is a file that resulted from the build, maybe I have a file that lists down the commit ID, the hash, and all these things, then that file maybe needs to be stored in a central location, and that central location could be your S3 bucket or your EFS file storage, or it can also be GitHub. So here we are just saying you will publish the artifact and metadata. So what is SBOM? SBOM is software bill of materials. So your application could be using multiple things. For example, if I'm developing a banking application, I might require a calculator. Now, I do not want my developers to start writing the code for a calculator, because there are plenty of well-known libraries for calculating stuff. For calculator, my developers would instead use that library. Now, why use a library? Because libraries, they ease your job, they reduce development cost, improves reliability, especially if you are using a well-known library, and it saves time. So your developers, if they are working on the core banking application, they could be leveraging plenty of libraries, and their application can have multiple dependencies. So everything related to your application constitutes of multiple chunks. So all these chunks, SBOM will list everything. So the textbook definition of SBOM is, it is essentially a formal, detailed inventory of all the components, libraries, and dependencies used to build a piece of software. So it can be thought of as an inventory. So this is what happens in this stage. And this stage, as you see here, typically should be finished within 5 minutes. Now, why the time constraints are important? Understand that while this feature is built, we want everything to be fast here. When you are dealing with trunk-based CI/CD, you do not want jobs to run for 30 minutes, 20 minutes. You want the entire pipeline to be completed within the minimum possible time, because there will be other features on which developers are working. Now, if you are working here, then you do not want multiple pipelines to be running in parallel. You want these things to be sequential. At least you should be trying that things do not run in parallel, because if things run in parallel, then there could be merge conflicts and so on. We will see a few scenarios where we'll talk about this, but for now, aim to trim your pipelines to run at the minimum time possible. It should consume the minimum time possible. The third step is, let's say the branch job succeeded. Now, why we are calling this a branch job? Because your developer worked on a branch and pushed it. Okay, so we are calling that a branch job. Next, we have a PR job. Now, why a PR job? If the branch job succeeded, then what your developer will do is, your developer will open a PR, and as soon as a PR is opened, a PR job gets triggered. But Varun, why a PR job will get triggered? Understand what we learned here. Jenkins multi-branch pipelines will scan your branch, PR, and tag. So here it ran a job when a branch was pushed. Here it will run the pipeline when a PR is created. Now the tasks that are performed in this and in here are different. Understand? So here we are performing some more testing. What we are saying is triggers on PR open or update. If a PR is open or PR is updated, it will trigger a PR job. Runs light SAST, and SAST is static application security testing, plus dependency scans. Now dependency scans on codes and manifest. So example, if you are dealing with Maven, you will have pom.xml. If you're dealing with Python, you will have requirements.txt. What it will do is all these files, they have the dependencies of the application or the packages that are required. That's why it is called a dependency scan. So what dependency scan will tell you, it will give you a graph that this is your application, this is the dependencies, and these dependencies have these vulnerabilities. Now how the vulnerabilities, because there are tools that can compare the dependencies that your application uses with a vulnerability database, so that it can tell you that this is how vulnerable or how not vulnerable your application is. Now you do not have to do this manually. Okay, there are tools that can be leveraged for this, tools like Sneak, Trivi. You can integrate these tools with your pipelines. If you learn about DevSecOps in future, then you will understand more about these tools, because these tools are specific to security, vulnerability management, and so on. But as DevOps engineer, I'm not saying that you should not know about these things. Maybe you should not know about these things as deep as a DevSecOps engineer, but at a very high level, you should understand what these tools are. But if you are a senior DevOps admin, you will be expected to implement these tools as well. Maybe you do not know those things as deep as your security engineers, your DevSecOps engineers, but you are still expected to configure these tools. The next one is deploy ephemeral preview. I am not saying deploy onto staging, development, or production. I am saying deploy onto ephemeral. Now, why is this deployment necessary? So whatever testing we have performed thus far, be it your compilation, unit tests, lints, coverage, and here SAST dependency scans, we have performed these things in a static code. But there are certain things that cannot be done until and unless the application is in running state, which is why to perform certain tests, we want the application to be running. And here in the PR job, we are deploying that application onto an ephemeral hardware. Now, that ephemeral hardware or that ephemeral part could be a different namespace in Kubernetes, or if you're dealing with traditional, it could be an ephemeral virtual machine where this code is deployed. Why we are saying it ephemeral? We are saying it ephemeral because this will be teared down if the PR job completes successfully. If it doesn't complete successfully, then you may choose to not tear it down and troubleshoot the problem and then make changes in your code so that it gets deployed onto the ephemeral environment successfully. But for now, understand that ephemeral environment is supposed to be teared down once the application is deployed successfully, or if it is not deployed successfully, it is your decision on how you want to deal with it. Then what happens once the code is deployed onto an ephemeral environment? You perform integration and smoke tests. What are these tests? These tests will tell you whether the basic functionality of the application works fine or not. If you are in a banking application, whether users are able to check their account statement, so this becomes a smoke test, or quickly tell you whether the application is accessible or not. So these minimal tests which can be performed quickly are integration or smoke tests. So these are performed. Once these are successful, then the code is merged with the main, and we'll look into that. So this ephemeral environment is teared down upon PR closure or PR completion. Now that the PR job has completed successfully, we can successfully merge this with main. Now there are certain things that also happen before this merge is performed. So there are these tests which I already told you. All required checks green, that must be there, and let's say all of these completed successfully, including deploy succeeded in the ephemeral environment. Let's say that was also successful. Next is enforce required checks. These are the required checks plus up to date with base. Now, what is up to date with base? That's what I just told you. Imagine this branch feature UI font was created at this stage, correct? Now, what if there was a new commit here? This was a new commit here. In that scenario, this branch will not have the changes that were part of this commit, and this commit was resulted, let's say, from a new feature on which a different developer team was working. So we are at loss because we are not working with the latest code here. In that scenario, the PR, it will not be merged with main because we do not have the latest code with us. Now in this scenario, you could rebase or merge with this new one and then rerun your pipeline. That is why I said your pipelines should be running extremely fast, because if you are running your pipeline and your pipeline is taking 10 minutes to run, but there is a different PR raised which just takes 3 minutes to run, then your pipeline is already stale because your pipeline, your branch does not have the latest code that is here. You are still working with the old code. Hence, enforce required checks plus up to date with base is important. If red, fix, push, rerun PR job, and that part we already understand. Now once this gets merged, understand that merge will result in a new commit in the main pipeline, in the main branch, and if there is a change, Jenkins will rerun the pipeline in the main branch. If something is not connecting right now, do not worry. In demo, all of these things will make sense. So in the fifth point, we are saying merge to main pipeline runs on merge, reuse signed artifact image. So like I discussed in the previous lectures, that you only build once and then you promote the same artifact. So the container image essentially is only built once and then it is pushed to ephemeral, to stage, to production, and so on, and then deploy to dev stage, verify, promote with approvals. Now I told you that there is a single line that is releasable. This is the main branch, so you could be first deploying onto the dev environment from this main. Understand the difference between these branching strategies. Okay, so if you were dealing with git flow based branching, then you would have dev branch, prod branch, pre-prod branch, and so on. But we are talking about trunk based CI/CD. In trunk based CI/CD, it is only the main branch that holds the code, and then this main branch deploys to all the different environments, your dev environment, your stage environment, or your prod environment. Then the sixth step is git host auto deletes source branch if enabled. So once this merge is performed successfully, like we discussed before, this will be deleted. Jenkins will also prune the job because it does not see that branch anymore. I hope this makes sense to you. Now we will do a demo that will connect any dots that remain to be connected. So let's scroll down, and this is what we are going to do. So let me quickly explain this to you, what we are going to do. Jenkins Multibranch Pipeline Flask Docker demo. So what we'll be using is, we'll be using a private GitHub repository. Multi-branch pipeline will be created in Jenkins, and then we'll be performing manual scans for now. Don't worry, as we progress, we'll configure webhooks and all those fancy things. It is just one click and you can configure those. No biggie. Right now we'll be performing manual scans. So our step 0 would be to create an MBP job, multi-branch pipeline job. We'll define the job and then we'll set up the credentials, because we know we are connected to a private GitHub repository. Our Jenkins must have those credentials. So we already have those credentials saved from our past lectures. We'll be using the same. Then we'll be scanning our private repository, and our private repository must have our Jenkins file for the scan to be successful, because Jenkins file must be there. Then we'll run main baseline build. Understand, I told you the pipeline will detect the main branch quickly and it will run the job. And the same will happen when we move to the next step of the process. There will be a new pipeline job created automatically for us when we create new branches. So in step number 1, then we'll be creating a branch. In step number 2, we'll be dealing with a branch job. Here we will be building an image, pushing it to the registry. We'll be deploying a container on port 5000. We'll also have a file generated, deploy-info, which will contain the details about that build. We'll be archiving that file. If you have been with me since day 1, you understand that the workspace that gets created is temporary. You have the option to clean up that workspace. But if you archive something, that gets stored in the jobs directory in Jenkins home, and that place is there to store your artifacts as well along with your job. So here in this step, we'll be archiving deploy info. In step number 3, we will be raising a PR in GitHub. So I should also tell what was happening in step 1. In step 1, we create a branch, and then we create a branch called feature UI, and then we edit the code. We make some changes. We add a line in the UI like actual development will work, and then we will push that branch. And as soon as you push that branch, step number 2 will kick in, and we have already discussed what happens in step 2. And once step 2 is successful, we will move to step 3, and step 3 is we will raise a PR in GitHub. And as soon as Jenkins detects there is a PR, Jenkins will run a PR job as well. In step number 4, we will see that we'll merge the PR because the checks are green. We'll merge that, and in the 5th point, the main deploy will happen, because here the PR is approved in this step. Once the PR is approved, the main will have a new commit. The main will have the new commit, then Jenkins will detect it. Jenkins will detect it and runs this CI again. So it will detect the merge, build, push, deploy, archive, test on main, and we will verify. This can be thought of as a smoke test. We'll verify that our application is accessible or not. And here in the 6th step, we'll be doing a cleanup in GitHub. We'll auto delete the feature branch, and in MBP, in the Jenkins side, the prune retired branch jobs or workspaces. So whatever was created temporary, for example, for the new feature branch, will be pruned, because the feature branch will no longer exist in GitHub. So we'll be doing all of these things in this demo. So let's get started. And before I do that, I'll take you to the GitHub repository for this course. Now I have already created this Cloud with Varjosh private repository, and we created that I think in day 5 where we did the first demo. I'll let you do that. If you do not have this repository, just create a private repository and upload these files. What are these files? You can find in the repository for this lecture. So this lecture's repository is day 7. In day 7, you have a Python directory. Just upload everything that you see here in the private repository that you create. Now, what happens in this, I want to quickly show that to you. There is a Docker file here, and that Docker file is simply using the Python 3.11 slim base image. The working directory is /app requirements. We are just installing one package, that is Flask, because our Python application uses the Flask framework. We are running pip install Flask, and then we are copying our code to the working directory, which is /app. We are exposing our application on port 5000. Remember, it is port 5000 on which our application listens. And as we all know, this expose is just for documentation purpose. It will not open port 5000 in your application. You will have to do that. And we have done that, and I'll show that to you. Then we are finally running the application. So this is our Docker file. Then we have our app.py. This is our code. Our code is just saying welcome to cloud with Varjosh. Tip is built with Flask, shipped by Jenkins, running in Docker. And here we are saying our application listens on port 5000. As simple as that. And this is the main piece. This is our Jenkins file, which we have constructed. It has various stages. It has a push stage where we are pushing the built container image. Then we are in this stage deploying this container image. If I come down, then in this step itself, we are creating a deploy info file, which will have the build number, the image will have the repo name and the tag, we'll have the commit ID, git commit ID, we'll have the branch, and so on. Then we are finally deploying this image onto our Docker host, and Docker host in my scenario is my Mac machine. And then lastly, we are performing a cleanup. There are also certain post actions that we are performing. On success, we are echoing this. On failure, we are echoing this. And no matter if it is success or failure, we are echoing the job is finished. So it's a simple Jenkins file. And if you do not right now know how to create Jenkins file, I would urge you to watch this series in sequence, because we learned this in day 5, day 6, and so on. So now that we have this understanding, let's go to the Jenkins screen. I'm in the home page, localhost 8080. In here, I will just click on new item, and what I want to name this is MBP Flask. And let me zoom in a little. Here I will choose Multibranch Pipeline. Creates a set of pipeline projects according to detected branches in one SCM repository. I'll click here. I will click on OK. And display name, I will leave blank. Description, I will leave blank. And here is the important piece. I see branch sources. Now, what is the source of your branch? I could choose Git, I could choose single repository and branch, or I could choose GitHub. Now, why do I see GitHub? You see GitHub under branch sources because GitHub branch source plugin is installed. If you are using any other source control, then you should check the branch source plugin for your Git host. So I will click on GitHub, and this will give me all the options related to GitHub. So what I will do is, first I will paste the URL. I'll go to my private repository, because hello, URL is important, and that's how Jenkins will be scanning my repository. So I will copy this name. I will come here. I will paste this here. And if I click on validate, this won't be successful because this is a private repository. I must provide credentials, right? So we already added credentials for our GitHub. If you do not have the credentials right now, go to GitHub, create a personal access token, and then add those credentials. If you do not know how to do it, I recommend you watch the previous lecture. So I'll click here, and then I'll click on validate, and this should succeed. Credentials, okay, this is what you want to see. Now I will scroll down. Behavior. Now this one is important. Discover branches. What is your strategy? First one is exclude branches that are also filed as PRs. Now this is the recommended option. What this says is build the branch until PR exists, then build the PR job to avoid the duplicates. So let's understand it diagrammatically what we are saying. I'll go to draw.io. Okay. And what we are saying here is, so you have pushed a branch. If there are pushes in the branch, you keep building those pushes. Okay. And that's understandable. Now, once my push is succeeded, once my branch job, let's say, is succeeded, I would want to raise a PR, right? And once there is an opened PR, you stop running the branch job. And that is what we want. What we want is, if there is a branch job, let's say you pushed a branch and that branch also had the Jenkins file. So your Jenkins will detect it and it will run the branch job. That is what you want. Let's say your branch job failed. You pushed again, and this time your branch job failed again. So you pushed the changes third time, and this time your branch job succeeded. Okay. Once your branch job succeeded, you raised a PR. And as soon as you raise a PR, your PR job starts. You do not want, when a PR job is raised, if someone else pushes to this, there should be a branch job run. You don't want that. If a PR exists, you do not run a branch job for me. As simple as that. And that is what we want. And understand, when this PR job is closed, the PR that you raised is closed, you can again push and run the branch jobs. But understand, if this PR job is successful, most of the times you would want the branch to get auto deleted. In that case, it does not matter, right? So what you want is, you want this setting: exclude branches that are also filed for PR. So in this option, what will happen is, build the branch until a PR exists. As simple as that. Then build the PR job to avoid duplicates. Second one says, only branch that are also filed as PRs. Now this is saying build branches only when they have a open PR. Now be careful with this, because it will not build in generic pushes. So if you are pushing to a branch, it will not build. It will only build when the PR is raised. So essentially, this part will not be there at all. Only this part will be there, because it is only running when there is a PR job that exists. The last one is all branches. Build every branch. Simple, but can double the builds when PRs exist. And that's understandable. So I hope this makes sense. And also, I have explained these pointers in the GitHub repository as well. So go to that GitHub repository and revise these concepts. Next one is discover pull requests from origin. Now let's see what are our options here. So here we will choose the recommended one and then discover pull requests from origin. The selected one is the current pull request revision. Now this says only build my code. So for example, whatever code was here, just build that code. So build the PR tip essentially. The next option is merging the pull request with the current target branch revision. Now this says your code plus the current main. But Varun, why is this important? Understand, if I just build this, the PR may fail because there could have been a new commit here. If I build this and then I try to merge this, the merge will fail because it is not up to date with the main, because there has been a new commit since this branch was created. What I want you to do, Jenkins, is I want you to test my code, plus I want you to see what will happen when this merges with this, the current one, the current main. So you check with this option, merging the pull request with the current target branch revision. So you test my code with the current main revision, so that I know if I try to merge with this one, how will my code behave. So essentially, this is telling you beforehand what will happen if you try to merge this with the main right now. It will give you the proper perspective, because it will take your PR tip and the head tip. Last one is, if you have enough compute resources, I would suggest to always use this. Both the current pull request revision and the pull request merged with the current target branch revision. So what this will do is this will verify both the views. First, it will run on your code only, this one. Then it will run on your code plus the current main tip, which is this one. Now, why this is important? Again, I'm saying if this commit was not there, then you might not need any of these things. But what if someone performed a new commit and your branch is no longer the latest? In that scenario, you would want to test what will happen if I try to merge it right now. And if you try with this one, my results would be successful. And if you know these will be successful, then you perform your rebase and merge and whatever you want. But this will tell you beforehand what will happen if you try to merge with the current main tip, with the latest main right now. And this is the latest main, so this will only come once the merge is successful. So this is essentially your merge commit once the PR is successful. So I'll remove this. I hope all of these makes sense to you. I will choose this one. And if you go to GitHub, here I have explained all of these things, both current and main, what will happen, 2 builds per PR update, head and merge. Here you will see a synthetic merge, and this merge, whatever happens, is a synthetic merge. It's a temporary merge, because understand, a merge will have to be performed to see what will happen if this merges with this one. What will happen now? For this to happen, it won't actually merge your code. It will perform a synthetic merge, a temporary merge, to see what will happen, and it will tell you the results for that. So I hope this makes sense. Now let's go back to our Jenkins job. I will choose this here and discover pull request from forks. You will not be dealing with forks when you talk about enterprise private repository, so I will not discuss that, but I will encourage you to read about this as well in the GitHub notes. So I'll keep this at default. I'll also keep this at default. Here I will property strategy, all branches get the same properties. I'll keep this as is. Here build configuration by Jenkinsfile. So this is important. Jenkinsfile path, you can choose a new file as well, a custom file name as well, but I will leave it to Jenkinsfile, and it is present directly in the root of my repository, so it is not inside any path. I'll come down, discard old builds. I will let it be selected. Scan multiple pipeline triggers. So if you were polling your SCM, you could use this, and at which interval you want to poll that, you have different options you can choose from here. So I will deselect this because we will be running the pipeline manually. Appearance, this is fine, this is fine. Shared libraries, we have not discussed shareable libraries right now. Pipeline libraries, we'll see that later, but for now let's save this, and I want you to concentrate and see what happens. I'll click on save, and it has automatically started scanning my repository. This is so cool, folks. Now see, checking branch main, Jenkinsfile found, met criteria, scheduled build for branch main. It automatically did this. And if you see here, let me show that to you later. 1 branches were processed, checking pull requests, 0 pull requests. It has started detecting, finished examining this, finished branch indexing. It took 3.7 seconds, finished, success. Now let's go here, and no, let's go to this page. Here is MBP Flask. This is what we created. This is at the very top. This has a new icon as well for the multi-branch pipeline. If I click here, it has sub jobs, and if you see here, if you see this one has some new options: scan repository now, scan repository log, multi-branch pipeline events. But this is the pipeline job that it has created for the main branch. Why I know that? Because this is under the branch section, and here is a pull request section. So if I go to branches section, you see how this looks like. This looks like exactly like the pipeline job we created in the previous lecture. So that's what I said. MBP is an umbrella term. Then you can have multiple jobs inside it based on your branches and pull request. Now, since we only have main right now, you only see main and we don't have any PRs created, which is why you see 0 here. I'll click on main and you see here is the deploy artifact that we generated. And then here are the different stages of our pipeline. And if you see, it has taken action on main and ran the complete pipeline. The deploy is also successful. So if I access localhost on port 5000, then I will see my application is accessible. Welcome to cloud with Varjosh, built with Flask, shipped by Jenkins and running in Docker. And if I go to hub.docker.com and let me sign in quickly. And till this happens, I want to take you to the CLI. And here, let me run Docker PS. You see a container was created a minute ago. And that is when we ran our pipeline. So if I go to my browser again, and here you see cloud with Varjosh Flask, it was pushed 2 minutes ago. And if I go here, the tag that is being assigned, if I go here, there was a latest tag, there is tag number 1, and 1 is the build ID, which is why you see this here. I hope the dots are getting connected, and this will only connect if you have been through the past lectures and you understand what our Jenkins file is doing. Now let's go back to Jenkins screen, and we have seen this. Now let's do this flow. Now let's go to the diagrams and I'll show you what we want to do now. Now we want to create this branch. Okay, so let's go to our CLI first. I want you to know that I am in Jenkins basics to production directory. Firstly, let's go to day 7. Okay, I'll go to day 7 and I'll clear my screen. And here what I want to do is I want to clone my private repository. Understand that I won't be able to push to a private repository until I provide credentials. So in the first step, we will clone the repository, and I can only clone a private repository if I provide the credentials. So let me do that. I will paste this here. Now do not worry, I will be deleting this personal access token later. For now, I'm just showing this to you so that you can also follow along. Git clone origin. Now most of you would have seen that origin is named remote, but I don't like that. I want things to be detectable. If I see this name, I should be able to identify to which private repository this name points to, which is why I have named my origin Flask private. I have not kept it to the default, which is remote. Now if you go to the GitHub repository of this lecture, if I go here and if I go to the top, and then from here I go to first one, and if I scroll down, then you would see that all the instructions that I am following, you can find all these instructions here. Okay, so just follow along all of these steps with me so that it solidifies your understanding. So I'll go to the terminal, I'll press enter. Now as soon as I do it, oh, I think my token has expired. So hold on, let me do one thing. I'll press Control C, so more learning for you. So I will go to my GitHub repository, and then let me do one thing. I will scroll up, I will go here, and then I will go to settings. I'll open this in new tab, and then I will go to developer settings. Here I will go to personal access tokens classic, and here I will click on create new token. I'll choose the classic one, and here I will use my passkey. I'll touch my finger, and then I'll call this Jenkins delete me, because I'll delete it after this lecture. Validity 7 days repo, and then I will click on generate token, and then I will copy this token, and then I will paste this onto the command where I will be running this. I'll paste this, and then let's close this. I will now paste that command along with the new token here. And this is cloning, and the cloning is successful. If I press ls now, I will see cloud with varjosh hyphen private hyphen repo. So let's go inside this, and I'll again clear my screen. Now I will run git remote. This will show me that Flask private is your remote. So whatever push I will perform will be performed into this repository. So if I run git remote -v, you run it with caution, because this will show you your personal access token as well. So it will show me where exactly we are pushing. So if I run git branch -l, this will show me that I am currently working on the main branch. Understand that as a developer, I won't be working on the main, and I will not be able to push directly on the main because main is often protected. My main right now is not protected because anyone can push onto it. But as we progress with this lecture, I will show you how to protect it. Now let's do one thing. I will create a new branch. I will write git branch feature UI, and then if I run git branch -l, we'll see that feature UI is created. But we are currently working on the main branch because asterisk is against the main branch. So what I want to do is I want to switch to a branch called feature UI. Now a lot of folks also use checkout, but I prefer to use switch. And if you have any confusions, a small homework for you: check out the difference between git switch and git checkout and tell that to me in the comments section. So we have checked out feature branch. So if I run git branch -l, you will see the feature UI is now green, and it also has an asterisk. And if I run ls, you see all our files are here. Now we want to make changes into this file like actual developers will do. Vim app.py, I'll press enter. I will go in the insert mode. I will exit the insert mode. Then I'll press the $sign to move at the last of this line. I will go into insert mode. I will add a comma here, and then I will come here. I will write UI here is equal to this is my new UI. How do you like it? So this is what I have added. Now your developers will be actually modifying the code and doing some fancy cool things. So do not let that think that the flow will be any different. The flow will just be the same. We are modifying the code of our small little Python Flask application. In actual production as well, the flow would be same. I will hit escape, and then I will press shift ZZ to save this. Now that this is saved, I will hit git status. This will tell me that, dear friend, you have modified app.py. Do you want to commit these changes? And yes, I want to commit these changes. First, I will use git add app.py. I'll press enter. Then I will run git commit -m, and then I will write the commit message. Now this commit message should always be useful. So I will write updated UI to have a new line. And once I have done this, I will close this. I will press enter. Now, if I run git status, you won't see that file here anymore. And if I cat on our code, you will see that we have the new line. Understand that the modified code is right now in your feature branch. It is not in your main branch. So if I git switch main and I cat app.py, then you will see the old code. Understand, we are not disturbing the main. We are working on the feature branch, which is why only the feature branch will have our code. So once our feature branch has the modified code, we have committed that already. Now what we can do is we can push this onto our remote, and we already know if I hit git remote, you see that Flask private is already there. Now what I will do is I will write git push. Our credentials are already added. We added that in the cloning step. I will write git push flask private. This is our origin. I will name it appropriately, flask private. And where do I want to push it? Which branch? And the branch is the same. I'll have feature UI. So whatever changes that we did were only there in our local system. Those changes are not there in our remote. Our remote only has main right now, but now we want our main to also have feature UI branch. So I'll press enter and this will start doing the push. The push has happened. So if I run git branch here, it will show you that there are two branches, which is fine. But if I now hit git branches hyphen a, I think it will show me all the branches. It is also showing these are available locally. And if I talk about remote, remote has feature UI and main, and feature UI is there because we just pushed it. If you would have run this command before pushing, then you would see only main listed here. But now that there are two branches, it is showing both feature UI and main. And you see here, feature UI had recent pushes 2 seconds ago. Compare and pull. We won't be doing anything right now. I will hit refresh. And if I check here, you see feature UI is here. And if I go to the code of feature UI, it will have the new code UI. This is my new UI. How do you like it? And that is what we wanted. But if I go to our main branch, like I showed you before, our main branch will still have the old code, which does not have that UI line in it. Okay. Now there is a main branch for which Jenkins has already performed the build. So if I go to this, you see main, it has already built, and we also tried to access and it worked fine. What I want you to understand is, based on the diagram, what we saw before was, as soon as our private repository was scanned, a job for this main was triggered. And if I go to my browser again, you see the branch name main exists here. So what we just did was, we pushed our feature branch into our repository. That is why you see a main here and also the feature UI. Understand that this branch job that you see here, this should now trigger. Why this should trigger? This should trigger because we have a new branch, and that branch is called feature UI. The CI should start for this branch. Now since we are not using webhooks, what I will do is, I'll come here and I will click on scan repository. Now when it scans, it will see that there is a new branch, and that new branch has the Jenkins file. So what I should now do is, I should also build that branch. And what I want you to observe is, you are not telling Jenkins anything. MBP is taking action automatically based on what it sees in your repository. We are scanning it manually right now, but imagine if you were using webhooks here, which we will later in this course, you will not have to do anything. All these tasks will be automated for you. So if I hit refresh now, you see there is a feature UI here. Understand what we learned. The jobs can be triggered. These pipelines can be triggered based on PRs, branches, or tags. So branches we have already seen. For main and for feature, this pipeline got triggered automatically. Essentially, child jobs were created for main and for feature. And in the next step, we will raise a PR. PR for what, Varun? We'll be raising a PR for feature to get merged into main. And we will see that once we do that, the pipeline also gets triggered. And this time, this child pipeline will not be part of this branches. It will be part of pull requests because we will be raising a pull request for that. So now this has completed. Understand that right now we are using the same Jenkins file for everything, but when you are in production, like we learned in this diagram, you will have certain tests in the branch job, you will have some different tests in the PR job, and so on. As we progress with this course, we will see those things, but for now I wanted you to understand the multi-branch pipeline concept, which is why I have kept the pipeline simple. In upcoming lectures of this course, we will modify our Jenkins file to do different tasks at different stages. So for a branch job, there will be different tasks. For PR, there will be different tasks, and so on. For now, we are doing the same tasks. So I will go back here, and this time I'll go back to the browser, and you see this job has completed. So now if I go to this tab, you see what is being displayed right now is the code that was in main, and main did not have the UI line. So what I will now do is I will hit refresh. Understand that whatever we have been deploying, all of these are being deployed in my Docker host, and my Jenkins file at the very last has a line which first deletes the existing container and then recreates the container. And this time when it recreated the container, it used the code that was there in the feature UI branch, and the feature UI branch had the code that had the UI line. So if I go to this feature branch UI and I go to app.py, this has the code which has UI. This is my new UI. How do you like it? Which is why you see it here. Understand that our main branch still has the old code. So if I go to my main branch, the code there is still this. It does not have that UI line, but I want you to understand as we progress with this lecture, we will reach this stage where we will be merging to the main. And when we reach that stage, you will see that your main also has the modified code. So we'll see that as we progress. So for now, you saw that a branch job was automatically created for feature UI. So let's go back to the diagram and see what we want to do next. So step 2 is done. Step 3 is create a PR. So let's open a PR. So I will go to my browser. I will go to this repository, cloud with Varjosh private repo, and here I see compare and pull request. So let's raise a pull request. You can either click here or you can go to the pull request section and click on new pull request. I will use this one. I will click here, add a title, update UI to have a new line. I want you to know that have good titles which can be easily identified, because when you go to the Jenkins UI, under the pull request, the job that will be created will have the same name as the title of the pull request. So keep that name helpful. Updated UI to have a new line. I'll just add cloud with Varjosh so that it can be identified easily. You can have detailed descriptions when working in production. You must have detailed descriptions so that your peers, your collaborators can understand what this engineer was trying to do. I will just write a description here so that we have something here. Otherwise, you can even have markdown language. So you can have bold, italics, and so on. So I will click on create pull request. Understand that right now a pull request has been created. We have not merged it, but what we learned, when a PR will be seen in the repository, the Jenkins will trigger. So we have not configured webhooks. So what I will now do is I'll click on scan repository now. And as soon as I click here, we should see that it should identify that there is a pull request created in the private repository and I should take action, and I see something is happening here. So let's hit refresh. Understand, this is extremely critical. You see there are two things here, but Varun, we just created a single PR. Why do I see both? Read carefully. This is the title we gave, and in parentheses this one has head and this one has merged. And I want to take you back to how we configured. What did we say in the PR section? Discover pull requests from origin. We said we want you, Jenkins, to build both the things. I want you to build my feature branch, and then I also want you to perform a temporary merge wherein you tell me what will happen if I merge this PR with the main right now. And that is exactly what it is doing. It has created a synthetic merge. It will not actually merge your code. It's just a synthetic merge, a test merge, a temporary merge, so to speak. So it will just give you what will happen when in future you will be merging that. And I chose this option because this will tell me beforehand, before even I try to click on merge pull request, it will tell me beforehand that Varun, your merge could have problems or it could be successful. Both options are there. So that is why you see you raised a single PR and there were two jobs that were created for you. So let's go back here. Let's go to PR. But why has this head job failed? Head job is the one that is being run for on our code, that is the feature branch, the PR that we just raised from the feature branch, and then this is for the synthetic merge. So the PR head failed. Now there is a reason for this failure, and I along with you want to dissect this so that you understand. I deliberately chose this option to show you how two jobs will come here. So we have learned that point. Now I want to tell you why there is an error. So let's click here, and if I go to stages, I can see that deploy stage had a problem. So if I click here, and if I click here, it is saying Docker error response from daemon conflict, the container name this already in use, this. You have to remove or rename that container to be able to reuse that name. But Varun, why have we not received this error thus far? And the answer to that question is, let me take you back to my private repository so that I can show that to you, because that's extremely critical for you to understand. See, my code, if I go to day 7, I have this Jenkins file here as well. If I don't have it here. Let's go to day 6. Day 6 has the Jenkins file. I'll upload the Jenkins file in day 7 as well. So if you see my Jenkins file in the deploy stage, what I am also doing is I am removing this container. I am saying if there is a container with this name, you remove that. But why did we face an error? We faced an error because both of these jobs ran simultaneously. They tried to deploy a container simultaneously and only one succeeded, the one that finished a fractions of seconds before, and the second job did not have time to run this command. It happened so fast, which is why you only see one container being deployed. And if I go to my CLI and I run docker ps, you see there is only one container that was created 3 minutes ago. The deployment for this container failed, and for you the job could fail for head or the job could fail for the synthetic merge. It does not matter. But now you understand why one of these jobs failed. I also want you to clearly know that we are deploying onto the same Docker host. In actual production, maybe the branch job will have different steps and it will be deploying to somewhere else. Maybe the PR job will be deploying to a different namespace in Kubernetes, or they are deploying onto the same namespace with just different names for the pods. understand that these things are project specific. In this lecture, I want to concentrate on MBP, multi-branch pipeline, how the deployment part is done, what different steps each could have. We will see as we progress with this course. So now that we have the understanding why this failed, the PR, the second job failed, let's go to the GitHub UI and see what messages do we have here. So I'll hit refresh here, and then it says one failing, three successful. Check, and we know which one is failing. The PR head is failing, so which is what we see here, the PR job, the head, that has failed. And if I come here, so it is saying the branch job succeeded, the PR merge job also succeeded. This git guardian security checks, I did not configure that. This is automatically available by GitHub. What this will do is it will scan your repository to see if there are any secrets that you have committed by mistake. And you all must know that it is a best practice to never ever commit your sensitive information in your GitHub repository, even if it is private. So now we see an option to merge this pull request. We could merge it, but what I want to do is I want to do this cleanly. So let's do one thing. I will go here, I'll go to configure. Now that we have learned what happens when both of these are selected, let's just change this to the current pull request revision. I will save this. Okay, and then I will go to my GitHub repository, and this time I will hit git branch. Let's see, we are in the feature UI branch. I will hit vim app.py, and this time I will add one more line here. I will go at the very last. I could have used the $sign as well, and let's write here, we modified it again. Okay, I'll save this one. I will write git add app.py, then I will write git commit -m added one more line to the UI, and then I will close the double quotes. I'll press enter. I will write git push flask, and I want to push this to the feature UI branch. I'll press enter, and this has done the push. Now if I go back to the CLI, I see, if I hit refresh, I see there is a pull request. Understand what we learned. When there is an open PR, the branch job will not run, which is why I don't see a new job here. I just pushed it to the feature branch, but I don't see a branch job. But what I see is a PR job. Why a PR job? Because we chose that option. Understand, everything is connected. So if I open this to the new tab, I go here, I go to configure, and if you see this, we said that exclude branches that are also filed as PRs. So we have a PR opened, we did not close the PR, which is why you see a pull request ran. So if I refresh this now, you see this is my new UI. How do you like it? We modified it again. So if I go here again, I want to do one more thing now. We said that there is also an option via which we can delete the feature branches once the merge is successful. So if I click on merge pull request right now, this will not delete my feature branch automatically because I have not configured that. So let's also configure that. So I will go to settings here, and in the settings I will scroll down, and here you see these things are for pull requests. So what I will choose here is automatically delete head branches. After pull requests are merged, you can have head branches deleted automatically. So in our scenario, as soon as we click on merge the pull request, our feature branch will be deleted automatically. I want to show you one more thing. So while we are at it, let's also protect our branch. Now I am using a freeware version of GitHub. I don't have an enterprise version, which is why I can just enable that feature, but I cannot enforce it. So if you have the pro version, of course you can enforce it, and I'll show you how to configure it. but then it will not be applicable for me because I'm running a freeware version. So I'll click on add classic branch protection rule here. I want that protection rule to be applicable for main, and I want require a pull request before merging. When enabled, all commits must be made to a non-protected branch. In our scenario, the non-protected branch is feature UI or any feature or bug fix branch that is created. Our protected branch is only one, which is we have specified here. You can specify multiple branches, you can have different patterns. Maybe you are calling your main release or production. It depends on your naming strategy. For us, it is main. I will uncheck require approvals, and then as you can read, non-protected branches and submitted via a pull request before they can be merged into a branch that matches this rule, and for us it is main. I will scroll down and I will encourage you to read all of these options, and then you can read it here. Your protected branch rules for your branch won't be enforced on this private repository until you move to GitHub team or enterprise organization account. So I want you to keep this in mind. So let's go to the pull requests, and in this screen I will merge it. I'll go here, and now I will scroll down. I will click on merge pull request. You have to have a proper commit message here. I will click on confirm merge, and I have done the merge. Pull request successfully merged and closed. And let's notice two things. First is we want the feature to be deleted. We enabled that thing, so it should be deleted automatically. And second, I want to see a branch job here, because understand, the main just had a new commit. So if I go to my draw.io, we have merged to main. So we are here. There is a new commit in the main branch. Jenkins should automatically scan that and do the deployment of the new container for us, and we know that container will also display the same message. So let's go here. I will hit refresh. I'll have to scan a repository now, and it will detect that main just had a new change, a new commit. Last success was 20 minutes ago. Let's hit refresh. Oh, it's something is already running. If I go here, and you see main has started again, it is in progress. So if I go here, a build 2 has started, and if I go to hub.docker.com, we will see the resultant image here itself. So if I hit refresh, the code has not yet deployed because the pipeline is still running, but I want to show you the other thing that we did. So I will scroll up, I will go to my repository, one branch. Our feature UI branch, folks, is automatically deleted. So if I go here, I don't see anything, but I want to show you an interesting thing now. If I go to app.py, this has our new code. Now understand, the main did not have the new code until and unless a successful merge was performed. Now that our merge was successful, you see there is the modified code here. UI, this is my new UI. How do you like it? We modified it again. So I hope all these dots are getting connected, and this will have the same message even if this deployment succeeds, and it has succeeded. Our Docker Hub should have an image with the build number, because that is what we specified in our Jenkins file. We said our images should have this tag. So image and tag, this tag is the build number. So if I go here, if I sign in, I don't know why I get signed out again and again. I think I clicked on keep me signed in. Anyway, so if I go here, if I go to tags, you see there is a latest tag, because hello, that is what we specified. We were pushing two tags. One is the latest tag, and there is another tag, and this tag had the build number. Since the build number for this one is 2, which is why you see the pushed image has 2 as a tag. I hope all the dots are getting connected. So what we saw is, if I go back to our diagram, in step 0 we created an MBP. Then we saw the main was automatically considered for the pipeline. The job ran for the main branch. Then we created a new branch. We pushed that new branch to our GitHub repository. And then what we saw is a branch job was triggered. Then once we raised a PR job was triggered. And then once we performed the merge, our code was merged with the main, and then finally a cleanup was performed. Our feature branch was deleted from GitHub. In MBP also the retired jobs were pruned. And if I go back here in the Jenkins, if I go to this one, you see last success was 3 minutes 36 seconds back, and there are 0 pull requests now, because all those pull requests are now pruned, because there are no existing pull requests in my GitHub repository. And right now my repository only has the main branch. So if I click scan repository now, nothing will happen, because there has been no new commit and we have not pushed any new branch. I hope all the dots are connected. That wraps up day 7. We set up multi-branch pipelines, configured branches PR discovery, ran builds via manual scans, and used our Jenkins file to build, push, and deploy the Flask app on port 5000. Then we opened a PR, merged to main, rescanned, and verified the running container and updated code. In the next lecture, we will talk about Jenkins agents. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.